Hi, Megan. Absolutely. So we're given this formula, f of theta equals 2 cos theta minus cos 2 theta, and we're asked to find f of pi over 6. Okay? So that's going to be equal to 2 cos pi over 6 minus the cosine. Now this here, 2 times pi over 6, this is like 2 times pi over 6, right? That's like 2 over 1, so that would equal 2 pi over 6. And then we can just reduce that fraction to 1 pi over 3 or pi over 3. So it's really minus cos, I'll write it up here, pi over 3, like so. Okay? You can have access later, not now. So let's go ahead and just set that up. This is going to equal, so we have 2 times the cos of pi over 6. Wheel that in so we can see it. Now we have to figure out what that is. The question asks us to use exact values, which pretty much means go to the unit circle. Here's the unit circle right here. We're going to find pi over 6 in the unit circle, which is equivalent to 30 degrees, and we're going to take the cosine. Remember, because the hypotenuse on all of these triangles, if we were to make them as 1, the cosine is just going to be the x-coordinate of that point, which works out to root 3 over 2. So we basically have 2 times root 3 over 2. And we're going to subtract that with the cosine of pi over 3. Cosine of pi over 3 is right here. The cosine again is the x-coordinate, so that's going to be 1/2 minus 1/2. Okay, a couple different ways we can attack this. Basically what's going to happen here, we have to do the multiplication first, right? Order of operations, where we can really just cancel. So what we're left with here is going to be root 3 really over 1, right, minus 1/2. Now that's no good. We have to have common denominators, so we'll multiply by 2, top and bottom. So that's it. Now we have common denominators, and we can just combine the numerators, except that these are two different species of numbers, right? This is an irrational number, a decimal that goes forever. This is a rational number, -1. So we'll just write it as 2 root 3 minus 1 over 2. Over that common denominator, because when we add and subtract numerators, we don't mess with the denominators. All right, hope that helps, buddy. Let me know if it doesn't.